Hi, I'm Austin White, and this is a presentation on the impact of DDoS attacks, virtual machines, application containers, and system containers. I am a Gatton Academy student, and that's a special program for high schoolers to take 2 years of dual enrollment college courses at Western Kentucky University, and I'm technically in my second year of undergrad at Western Kentucky University taking computer science. So the overview of this presentation is I'm going to go over the introduction. I'm going to go into the background of the different topics involved with the experiment, the motivation for this experiment, how we did the experiment, and finally show a diagram of the overall setup, and I'll go over the results in conclusion. So, first is distributed denial of service attacks, or DDoS attack. This consists of a malicious user typically using multiple attack nodes to attack a single server that the client is using. And the effect of this is that the server will slow down or it can even crash. And it's very similar to working a job at a desk, and you're working and then all of a sudden you get a million orders of different people trying to tell you to do different things while you're trying to work and finish whatever it is you're working on. It's like overloading and overwhelming the server. And we're going to talk about distributed process execution environments, and they are just pretty much virtual machines. If you've worked with those, they are like virtual machines. Virtual machines are a type of distributed process execution environment, but for those of you that haven't, it is essentially having a second computer inside of a single computer, so that way you can isolate different tasks and jobs and applications. And lastly, our hypervisors, they are a part of virtual machines, and I'm going to get into that more in a second. So here we go. There's two types of hypervisors that are parts of virtual machines, which again are a type of distributed denial of service attack, which are two machines in one. You can have more than two, keep that in mind. But anyway, going back into this, hardware hypervisor in the OS is this type of type 1. This is faster than type 2 because you'll notice that it consists of the hardware, the OS, and then the hypervisor, and then the multiple OSs again. And this extra step of going through the OS for type 2 makes them slower than type 1. But they still achieve the same effect of having the hypervisor access the hardware. The hypervisor accesses the hardware. It may have to go through the OS, but it's still doing it. And then you have the multiple machines on this one hardware. Application containers are another type of distributed process execution environment, and they act much like virtual machines, except they have a different architecture. And the architecture is, you'll notice here, again, this is the virtual machine architecture. But on this side, you'll notice the application container architecture. You have different containers on top of a software process. Docker is a good example of one if you've worked with that. And then it's directly on top of the OS, which then goes to the hardware. And while here you'll notice for virtual machines, again, you have the different virtual machines, and then you have the hypervisor, like we talked about before, and then at the bottom is the hardware. And what we've noticed is that application containers are actually faster than virtual machines, especially Docker, because it's the step of going through the hypervisor is taken out, and it's just going directly to the OS. So this is operating system containers, and they have the same architecture for the most part as application containers. The only difference is that they were designed with using multiple softwares in mind, while application containers were made with using a single at a time. You'll have essentially application containers where if you wanted to host a web server, you would use one container for that. If you want to have a database, you'd use another container for that. It would be separated. That's, again, the whole point of distributed process execution environments, is separating out different processes, especially in software development. So this, getting into our motivation, many places use virtual machines, application containers, and operating system containers. And these are many different examples of each. I don't know if you've heard of Zen, KVM, VirtualBox, Docker, Kubernetes, CoreOS, OpenShift, LXD, LXC, OpenVZ, Linux VZ Server, BSC Jail, Solaris zones. But these are used by banks, they are used by big software companies like Apple, Java, Oracle has their own, and they actually made VirtualBox. That's their distributed process execution environment that they support, and these are commonly used in most applications, whether you realize it or not. So this is the approach for our experiment. We want to essentially take the three different types of process execution environments, the application containers, the system container, and the virtual machines, and put them on a defense node in a DDoS attack, and have 3 attack nodes attacking that defending node that's running the distributed process execution environments. And then what we're going to do is, during all this, we're going to benchmark the defending node to keep track of how it's using different computing resources. And this is all going to be done within one network. So here is a quick diagram showing that. So what we did was we had the internet to just connect a laptop to turn on and off the attack from the attacking nodes, and it did the DDoS attack on the defending node that had, again, the distributed process execution environment running inside of it. And this is just the router that's keeping this all isolated from the internet. So this was the results of 4 different types of distributed process execution environments. I don't know if you can see it due to the constraints of using this TV, but if you can look at the slides that should be attached, you should be able to see that we use Zen, VirtualBox, Docker, LXD as our distributed process execution environments. Zen is a virtual machine, a type 1 virtual machine. VirtualBox is a type 2 virtual machine. Docker is an application container, and LXD is a system container. And we wanted to, again, try to see how they varied, those different types of distributed process execution environments varied in their DDoS response. So here you'll notice just the baseline results of each for the file I/O. We wanted to measure and see how well it was doing local data transfer. And here is the CPU benchmark. We want to see how well the CPU was able to process different levels of tasks. And then here we measured the GPU frames per second for rendering a image. And then here is the network bandwidth, which we just measured by seeing how well it's able to transfer data over the network. And these were the baselines. So we did 3 different types of DDoS attacks. There are different types. Keep that in mind. So the first one we did was type 1, which was network targeted. So the goal for this DDoS attack was to have an adverse effect on the network abilities of the defending node or the distributed process execution environment as well, because it's housed on the node, defending node. So each of these graphs represents the change in the different computing resources that we were measuring. And you'll notice that LXD took a strong hit, if you can see that. And all of these took a strong hit as well for GPU, except for VirtualBox. VirtualBox managed that quite well. And change in CPU, you'll notice that Zen actually managed to maintain itself quite well. And network bandwidth, they all took a hit again, except for Zen. So I'll let you guys look at that more closely on the slides, but this is very nice to see. So this is, again, the change for the second DDoS attack that we did, which was CPU targeted. So its goal was to have an adverse effect on the CPU. And what you'll notice is that the file I/O benchmark for LXD again went down quite sharply. They all slightly went down in frames per second, except for Docker, which took a strong hit. Network bandwidth, VirtualBox did very well in this situation. Docker not so well. And then you'll notice here that VirtualBox actually was, again, mostly unaffected for CPU. This is the third DDoS attack that we ran, which was memory and CPU targeted. So its goal was to have an effect on the memory and the CPU and the defending node. And notice here that LXD actually managed well in this situation, and it didn't take that much of a hit for its file I/O benchmark. And then the GPU it appears to be mostly unaffected. But when you look at the CPU, everyone took a hit, but mostly VirtualBox. VirtualBox struggled very much so in this scenario. And the network bandwidth, they actually all did quite well. And pretty much our conclusion, after running all the DDoS attacks on the network, on the defending node, and going through the data and looking closely, we noticed that under the type 1 DDoS attack, the VirtualBox was the most resilient overall. Under the effects of the type 2 DDoS attack, Docker was the most resilient, but Docker was also the most resilient to the type 3 DDoS attack. And we believe that differences among these, again, was due to the difference in architecture between the different types of distributed process execution environments. Remember, we tested type 1 virtual machines, which was Zen. We tested the type 2 virtual machines, which was VirtualBox. We tested we tested the application container, which was Docker, and we tested the system container, which was LXD. And looking at that, one might take this and say that, oh, maybe application containers are strong against the type 2 DDoS attack and the type 3 DDoS attack. So maybe we should look at using this for running this type of application, which may be vulnerable to the type 2 and type 3 DDoS attacks. And that's the end of my presentation for the most part. Here are my references. And if you have any questions about this presentation or my paper, please email me at austin.kwb@gmail.com.